So let's talk about the Liskov substitution principle. The Liskov substitution principle, or LSP, is basically strong subtyping. And this is something that we really don't think a lot about in C Sharp. It's a little bit built into the language feature. But it's just a principle that you should be aware of. And we'll talk about an example of how you can not be aware of it on occasion. So S is a subtype of T, some class S, and it's going to be inheriting or implementing an interface of a class or an interface T. The Liskov substitution principle says that the objects of type S may be substituted for objects of type T. So any method or parameter or class that's going to use an object of type T will also be able to use an object of type S, and nothing bad will happen. The substitution will not significantly alter the behavior of the program in terms of its correctness or its overall task performance. Obviously, if you're going to be working with different subtypes, there is going to be a little bit of a behavior change depending upon the particular subtype, but that's intended. What we're talking about is we're not going to do anything bad that alters the application. We have those user classes from our earlier example, the admin user, the member user, and the guest user, and they inherit from user. So in our previous terminology, user is the class type T, and admin, member, and guest user are the subtypes S. So each one of those user subclasses must fully implement the user class interface. In particular, we don't want to see any not implemented exceptions, because obviously that's going to cause a problem for the application. Client of this user type is going to treat it like a user, run a method, and expect it to be implemented, and it will throw an exception because it's not implemented. That's not good. So we can't have that. And that's the basic idea behind the substitution principle. The interface segregation principle is basically a simplifying principle. It states that no client should be forced to depend on methods that it doesn't use. And what this turns into is splitting large interfaces into smaller, more specific ones. They're more focused on particular client roles. So the clients will only have to know about the methods that are of interest to them, and therefore we can have some roles. So when you've gone into .NET and maybe you've had classes that have implemented multiple interfaces, that's an example of interface segregation. Of course, all of those things could be combined into one, but a lot of classes wouldn't use all of those interfaces, and it would be a bit of a mess, and they would have to figure out really complex interfaces with lots and lots of methods. So splitting the large interfaces into smaller, more compact ones makes your code easier to refactor, change, and redeploy. It also makes it, in general, more understandable. So we're going to go back to our user classes again, and we have our base class user, and we have those subtypes. Our user interface should not include methods that are specific to the admin user, because the member and guest classes don't need them. So in that case, you would probably put in not implemented, which would not be good, or they just wouldn't implement that interface. So we split the user interface into perhaps two interfaces, one for admin and one for the other users. Or maybe we really need three, one for admin, one for member, and one for guest user. So we end up with an iUser interface, which has the basic methods, and an iAdmin user, which has the admin methods. And then we have our user class that implements those two interfaces. Dependency inversion is our last principle. And in terms of thinking, it's a little bit abstract. So stick with me on this. What it states is that high-level modules should not depend on low-level modules. It also states that both should depend on abstractions. So there shouldn't be any interdependence. And the abstractions should not depend on details. And the details should depend on abstractions. So what we're really saying is that both the high and the low-level objects must depend on the abstraction. And that way, those two objects are not coupled. It's basically an inversion of thinking. Quite often we think of high-level modules being parents and lower-level modules being children. And the high-level modules, therefore, understand who their children are, and we try to make sure that the children don't know anything about the parents. What this principle is really saying is the parents don't know anything about the children, and also the children don't know anything about the parents. But they do know something about a common abstraction. So here's a little bit more of a concrete example. Back to our original user class, and we want to be able to log exceptions. Now, we've already talked about this. We don't want the user class to log exceptions directly. So we're going to use a logger class. We'll just create ourselves a logger class right anytime we have an exception, or maybe we'll make a method that says handle exception, and it will create our logger class. We're done. Moving on. Well, wait a minute. Our logger class has multiple types. It can be a file logger, a database logger, or a Windows event logger. And we followed a previous principle and made different class types for each one of those loggers. That means our user class has to know what kind of logger it should use, whether it be file, database, or Windows event, and it should create that particular type of logger. Well, if we get back to our S principle, our single responsibility, that seems like a whole lot of work that user class has to understand. Seems out of scope for a user. It also violates our dependency inversion. The user class has to know way too much about the logger class in order to make that decision. So instead, the simplest solution is that something else that understands what should be done passes a logger object to the user class, and the user class uses it as a logger, as opposed to a specific logger type class. And the factory method pattern allows us to create a logger of a given type. So the user class could also use a factory that creates a logger of a given type without the user class having to know what kind of type that is. It might get pulled out of a configuration file, for instance. So that's the basic idea behind dependency inversion. Different classes shouldn't really know a great deal about each other and shouldn't work very hard to figure it out. And those are the solid principles. And if you can think about these things when you're first creating your applications, it'll help you downstream avoid really nasty interdependencies that create bugs. It'll also help your application grow, particularly if you think about them when you're adding features. And try not to violate a principle while you're adding the feature. It's really easy to violate those principles because in some ways it's a shorter path. But in the long run, it'll end up biting you because later on, as the application matures and you add more and more features and your classes grow and grow, you're adding more and more complexity that becomes interrelated between the classes. And that's where some nasty bugs can come up. So following solid principles is a nice discipline to get into, and although it may cost you a little bit of thought time up front, it'll be worth it in the long run.